La segona sessió anirà sobre modelatge, simulació i ciència computacional i porta per títol The Truman Show Paradox, Distinguishing the Real World from the Model Using Simulations. La primera xerrada anirà a càrrec d'Arturo Valdivia i porta per títol A Swiss Knife for Interdisciplinary Studies. I anem-hi. ¿Cómo? Sí, esto no tiene más. El rojo es para las.
So, good day to everyone. Today I will to say something about all these phenomena that you have here. You can read line by line and realize that they all have something in common. And it is that if you want to model them, then you will need to work with a lot of data that might be overwhelmed. Maybe you won't have complete data, or maybe each of these phenomena is random in some way. See, if you have a research topic related to something to that, maybe this will be interesting. Today I would like to tell you that all of these pairs may be related by means of something which is called a stochastic process. When we are doing stochastic modeling, what we're trying to do is to draw some effective conjectures out of these models in order to get some hints about the real phenomena. For these pairs, you can find that, for instance, the first one, the suspended pollen and the stock market prices, are usually related by some stochastic process which is called the Brownian motion. A variation of the Brownian motion also models river levels and internet traffic. Maybe Markov chains are more familiar to you. You can use them for chemical reactions, decision making. This is one of my favorite ones because it's more related with my research topic. And with ambient processes, you can model fluid turbulence, electricity prices, and tumor growth. So on and so on. The idea of this talk is related to this famous, I don't know how to call it, maybe metaphor about the blind man and the elephant. Maybe you know it. And it basically says that if you take a look of individual parts of your phenomenon, then you will have a really based impression of it. So interdisciplinary studies, I think they will be in this line, right? Let me start with a simple example, or maybe just to present one example. Here we have the virus of Ebola. Maybe you know it, maybe because you study something related to that, or maybe because of all the bunch of movies they created about it. But maybe you don't know about this story. It's about a computer virus that can spread to humans. Interesting, right? And of course, as soon as you hear it, you will feel the need to share it. So we would like to discuss how epidemics can be related to rumor spreading. Well, in the case of epidemics, you know that the interaction between molecules or humans spreads the virus. In the case of the Ebola, it is an airborne virus. That means that you can infect someone if you touch that person, or even if you are in the same room, like right now. And it's basically the same that we have with the internet. You can tell the rumor to your friend next to you, or you can go to your favorite social network and spread it away. Okay? So the relationship here is infected people are spreaders, susceptible people are people which is not aware of the rumor yet, and immune people is people who doesn't have Facebook, like me, for instance, not willing to spread the rumor further. In any case, either infections or rumor spread, you have the same question. Suppose that you insert some infected people in a network. Under which conditions this epidemic or rumor spread can affect a large proportion of the society? Well, a simple model for this can be recovered by something which is called a rumor process. Well, this is a specific kind, where the infection can be spread only by your neighbors, okay? Following this graph. If you make some simulations, you can put some infected people in some places of the society, and this is what happened. In this case, you put a different amount or in different positions, the infected people, and you get a different outcome, and so on. Something which is related to the answer is something which is called the critical probability, which says that if the probability of infect someone crosses this critical probability, then a big proportion of the society will be infected. So in this kind of studies, it's important to find what's this critical probability for each rumor or for each epidemics. Well, this is all the time I have, so I only want to tell you thank you and ask you if you know this guy. It's the new zodiac sign. It's called Ophiuchus. I don't know if you know it, but maybe you can find it. And no, what I really wanted to tell you is that if you really want to make an extended presentation of your talk, you can visit us to our seminar. It's called Simba, and you will be very welcome to join us. Okay, thanks.